about similar figures. 2.8. All right, so before we can really talk about similar figures, we need to discuss what similar figures are. They are figures with the same shape but different sizes. And as long as they're both the same shape, then they're a multiple of each other. They are a ratio of each other. They're a proportion of each other. All right. So when we talk about similar figures, you can actually talk about their corresponding sides and angles. So first, let's start with this. Nope, not yet. Yep, you're going to want to. All right. So this first triangle I'm going to call ABC. And the second triangle I'm going to call DEF. Okay. When we are talking about corresponding sides, you can tell by the picture that those sides are not equal. They are similar. So when we talk about them, how I want you to write them down is if I say I have side AB, I'm going to put a line over it. Similar is just a wavy line. Similar to, and then what side over here is the same side as AB? DE. And you want to go in the same direction as this one did. So we went from A to B. We're going to go from D to E. Now what's another side? We have side BC is similar to what on the other triangle? EF. Very good. And again, you want to go in that same direction you went with BC. And the last similar side. Okay, we can say AC. Then we have to say what over here? DF. Exactly. The only thing is you just have to do the other one in the same order. So if you said CA, you'd have to say FD. Okay? Both are correct. So sides are similar, but I want to talk about the angles. Angles on similar figures are always equal. They're always the same. So when we talk about the angles, angle, and that's the symbol for angle, A, is equal to what angle in this triangle? D. Very good. Angle D. Angle B is going to be equal to angle E. Exactly. And angle C is equal to angle F. All right. So the very first question you have in your homework asks you to write down corresponding sides and congruent angles. Easy? Easy peasy, right? Okay, now we need to understand which ones go together so that we can start to solve missing sides of similar figures. Now, let's see, 9th grade that's in here, back when you had Mrs. Lacey, and she always set these up, do you remember, did she say big over small, small over big? How did she say it to you? I think it was big over small. Does that sound familiar? Okay. Okay. So, here is actually example number 1. I want to show you how this is going to work. Oops. Your directions are going to say, find the missing side of the similar figures. Yeah, that's what I think too. Okay. Bad X. All right. So in our first rectangle here, let's say that this side is 12 and this side is 4. And over here on our smaller one, this side is 6, and I want to know what the smaller side is here. Okay? Just like we did in our homework last night, we need to make sure we set up our two ratios exactly the same order. Okay? So we are going to start and go big over small every time so we don't get mixed up. All right? So we're going to take the big side, which is 12, and what is it corresponding to in the little triangle? 6 equals the big side, 4 over x, exactly. And now how would we solve this? Perfect. So 12 times x is 12x equals 6 times 4. Good. And then what do I do to solve for x? Good. Divide by 12. X equals 2. Okay. Thank you, Jordan. I appreciate that. All right, so let's do one a little harder now that we know how to set it up, right? Example number 2. Let's say I have a first figure here. Kinda. Well, let me fix it a little bit. It's supposed to, I don't know, kind of like one of those upside down volcano things, or I don't know. They're similar. Let's say these two figures are similar, okay? And I say the top of this one is 10 and the side is 11. And maybe the top of this one is 5, and I want to know what the side is to the smaller one. And no, it's not 6. I disagree. Okay, so let's set it up. Let's set it up. So we're again going to go big over small. So we're going to take 10 over 5. Okay, so we multiply the direction of our variable first. So 10 times x is 10x equals 5 times 11 is 55. Divide both sides by 10, and x equals 5.5. I do want you to go to 5.5. Now listen, okay? The reason today you're going to a decimal is because it's a length. It's a real life situation, right? So I want the decimal today when you're talking about the length of a figure. It depends what it says. No. No. You guys realize this is recording, right? Thank you. All right, let's try example number 3. All right, again, I want to find the missing side. So this time, let's say I have this triangle, and I have a similar triangle on the inside. Maybe the whole length of the big triangle is 100. And maybe the length of the smaller triangle is 75. And let's call this side 65, and I want to know what this one is. So we have a smaller triangle inside a bigger triangle. But they are similar. They're the same angles, right? Just different sizes. So again, if we're setting up as big over small, Good. 100 over 75. I agree. Equals. What's the other one going to be? Good. 65 over x. So now we cross multiply. X times 100 is 100x equals 75 times 65. What was it again, Libby? Okay. Thank you. And then what do we do? Awesome. Divide by 100. So x equals 48.75. Yeah, it is the same shape. I mean, yeah. So it is two triangles, one inside the other one. We actually end up doing that a lot in geometry class, where you have one inside another one, and you have to see both shapes. So that's fine. Correct. All right. So the three examples I just did all are problems 8 through 12, like problems like that. But we still have a ways to go, so let me keep going, okay? Next thing I want to talk about is scale. Scale was one of our vocabulary words. A scale compares two different lengths. And a lot of times we use this on a map, right? We said, for example, 1 inch. 1 inch might be equal to 100 miles, right? That's a scale. Sometimes they use them on the side of model cars, right? Because that's a scale to a big car. And they make a comparison. So we're going to use this scale to find other things. So let's say I have the scale 1 inch equals 100 miles. Here's example number 4. Let's say how far is 3.1 inches on a map. All right, so I really want to know how many miles that's representing, right? And granted, I gave you an easy one up here again, but I want to set it up. We're going to put our inches over our miles, and our scale is going to be our first proportion. So we're going to start by 1 over 100 equals 3.1 over x. Exactly. Well, we're talking about a scale this time. We can do big on top if you want, but a scale always goes in that order, so that's how I wrote it down. So x times 1 is 1x, and 100 times 3.1, 310. I agree, and it's 310 miles. Let's try another one. Here's example number 5. All right. A model of a fly. I don't know. Model of a fly. Sure, why not? Is about 4 centimeters long, with a wingspan of 5 centimeters. A model, or yeah, well, you know, a giant fly has a length of 2 centimeters. Think about a fly. It's only this big, right? A giant fly is a length of 2 centimeters. How big? That's a model. See? Model. How big is the wingspan? Is the wingspan. All right. So we are going to this time, and again, it doesn't matter as long as you do them both the same, we are going to do model over actual. Okay? So I'm going to start with the body. The body of the model is 4 centimeters. The body of the actual is 2 centimeters. Equals. The wingspan of the model is 5 centimeters. We're looking for the wingspan of the actual. How are we going to solve it? Go ahead, Isaac. 4x equals 10. We cross-multiplied, right? Then we would go ahead and divide both sides by 4. $2.5. Yes, that's all right. Okay, so this is what our lesson is about. Sometimes it's shapes where you're finding a side and they're similar. Sometimes it's insects. Sometimes it's model cars. So the whole idea is you're trying to figure out what that other missing side is. And the key to today is setting both ratios up the same. So what if I would have put actual over model? Would it change it? No, because you're still cross-multiplying to the same place, right? Any questions? Okay, your homework is only 6 through 28 even. It's not that many problems. The first, yeah, it'll be fine. Okay. Number 6, I want to remind you, I'm just asking for corresponding sides and congruent angles. Yes. What?